Okay, welcome back. Let's cover sections 3.1 to 3.4. I'm not going to cover everything in each section. I'm just going to cover the basic ideas from each of the four sections. Okay, so section 3.1 to 3.4 are on what we call determinants. Okay, let A be an n by n matrix n is less than or equal to 3. We define the determinant as determinant of A, is equal to A within these two lines, two vertical lines, don't get this confused with absolute value. It is not absolute value. Okay, if A is a 1 by 1, if A is equal to one element, A11, then the determinant of A is just equal to that one element. Okay, 1, 1, A11. Okay, number 2. If A is equal to a 2 by 2, A11, A12, A1, 2, 1, and A22, then the determinant of A is equal to A11 times A22 minus A12 or A21, I'll do A21 times A12. Okay, so we kind of use this type of a motion. We do this direction, and then we do this direction. Okay, so I kind of think it was as one swipe. Okay, I'm gonna get rid of this in a minute, but if I go this and then go around, it's A11 times A12 minus A21 times A12. Okay. Stroke it. There we go. Better. Okay. So yeah, we kind of go around like so. Okay, 3. If A is equal to a 3 by 3, then things get a little more interesting. We have A11, A21, A31, A12, A12, A22, A32, A13, A23, and A33. Okay, and then the determinant of A is equal to, it's kind of a long progression here. We take A11 times A22 times A33, that diagonal, okay, minus A11 times A23 times A32 minus A12 A21 A33, and then we add to that. Okay, so this is a continuation. A12 A23 A31 plus A13 A21 A32 minus A13 A22 A31. So that's the determinant of a 3 by 3. Okay. Okay, and there's a pattern here. It's not obvious just by looking at it, but we'll talk about how we could possibly derive this guy. Okay, and so we're going to look at a definition. Okay, let A be an n by n matrix the minor Mij, okay, of the element Aij is the determinant of the matrix obtained by deleting the ith row vector and jth column vector of a matrix A. Okay. Okay, for example, if I have matrix A here, and I have A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, and I want to get the minor of 1, 1, okay, M11. Okay, I would cross off the row and column that 1, 1 is in, and I would look for the determinant of what's left over, which is A22, A23, A32, and A33. And we define the determinant of a 2 by 2 as A22, A33 minus A32 and A23. Okay. Okay, so that's a minor. It's called the minor of A11 is the minor of minor 1, 1, and that's the determinant, okay, for 1, 1. Okay, that's the determinant. Crossing off the row and column gives me the minor for 1, 1. Okay, definition. Okay, the cofactor Okay, Cij, oops, the cofactor Cij of the element Aij of an n by n matrix is defined as Cij equals -1 to the I plus j power times m ij. Okay, so if I take I and j, okay, and I and j are both even or both odd values, then I will end up with a -1 to an even power, which will just be +1. So that'll be a positive. If one of each is even and odd, okay, either I is even and j is odd, or j is even and I is odd. If I only have one odd number for I and j, then I get a negative. And so what this does is it gives me something called a signed minor. Okay, this cofactor is just a signed minor. Okay, it's a signed minor. It's a minor that has a sign. It's either positive or negative, depending upon this kind of formula. Okay, let's look at the cofactor of 1, 1. Okay, that equals -1 to the 1 plus 1 power, m1, 1. Okay, which is just going to be equal to m1, 1. Okay, so that it's a positive value, a positive m1, 1. Okay, and so what's kind of interesting is this creates in a 3x3, the signs create a checkerboard pattern. It goes plus, minus, plus, minus, plus, minus, plus, minus, plus. So we just get the minors, and then I assign it its sign. Okay, I get the cofactor. Okay, sort of this checkerboard pattern. Okay, if n is greater than or equal to 3, we define the determinant as follows. Okay, choose any row or column of an n by n matrix A. If we expand along row I, then the determinant of A, matrix A, is equal to A11 times its cofactor I1, okay, plus I'm sorry, this should just be AI1, because we're not necessarily choosing the first row. It's AI1 times the cofactor of CI1 plus AI2 times the cofactor of CI2 plus ... and this continues for the entire row or column. And then we have A. Okay. If we expand along a row, then we just take all of the entries in that row and then multiply it by their cofactors. Okay, and then we get AIN times the cofactor IN. Okay, or if we expand along column J, okay, if we expand along column J, then the determinant of A is equal to A1J times C1J, okay, plus A2J times C2J, plus dot, 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 all the way for however many columns, for however many rows there are. This would be ANJ times CNJ. Okay, the cofactors. Okay, let's use this cofactor definition of a matrix to find the determinant of a 3 by 3 matrix. Okay, so number one. Find the determinant of -8, 7, 0, -1, -3, 6, 4, -2, -2. Okay, so what I want to do is I'll use the first row because it has a 0. I like zeros because then when I multiply it all goes to 0. So I'll take the first row, okay, and we'll expand off of our first row here. Okay, so if I want to eliminate my row and column, okay, then I'm going to get for my determinant, okay, we're going to get our first entry here, okay, which is -8. Okay, the determinant of A is equal to -8 times the cosigned minor. So what's the sign here going to be? Okay, well, again, with that checkerboard pattern, it's plus, minus, plus for the first 3 entries. Okay, so this is a plus -8, okay, or a -8 times +1, okay, times +1, times the minor. And what was the minor? The minor was the determinant, okay, of what's not included in that row and column. So that's -3, 6, -2, and -2. Okay. Okay, the next one is 7, but it's a negative of 7. Okay, so remember it's a signed minor, so this is minus, okay, minus whatever this guy is. It's a -1, okay, times my 7, so that's minus, well, maybe I won't do it in this example, but in the next one. Just know that this is a plus, okay, plus, well, let me go back to red. This is plus 7 times -1, because it's a signed minor, okay, times, okay, the determinant. Yeah, I'm going to bring this guy down. I don't run into things. Okay, and then, oops. Oh, what the heck? Okay. That's interesting. Good to know. Can we undo that? Yes, we can. That's great. Okay, perfect. Okay, so go back to my pen. Okay, and this is going to be looking at the, okay, next, okay, the next value here is 7. And so what I want to get rid of, I want to get rid of, okay, I want to get rid of the row and column that that 7 is included in. And so we're going to go boom, boom, and we can get rid of that, leaving the -1, 6, and the 4, -2, okay, for my minor. And the code would be the negative of that minor. Okay. And then we're going to add on the 0, okay, which is a positive 0. Okay, so we get, sorry about this. Just go away. Thanks. Okay. So we're going to get 0 times, this is now going to be a positive 1. Positive 1 times my determinant. Okay, again, cross off row and column. Okay, and I get -1. Okay, -1. -1 times, or, and -3. -1, -3, 4, and -2 as that determinant. Okay, so let's clean this up a little bit. Okay, so this is going to become -8 times 1, which is just -8. Okay, -8. And then the determinant of this guy is going to be -3 times -2 minus, it's always subtraction, okay, minus -2 times 6. Okay, plus 7, or -7. I'll just put -7. Okay. I would normally just put -7 right there initially and just say, hey, it's the negative of whatever's my second element is. Okay, but fine that we didn't do that this time. Okay, -7 times this determinant. So we're going to go -1 times -2. Okay, -1 times -2 minus 4 times 6. Okay, and then plus 0, 0 times 1 times, we really don't even have to do this because it's just going to go to 0, but I'll do it anyway. -1 times -2 minus 4 times -3. Okay, so we get -8 times 6 minus -12 minus 7 times 2 minus 24. Okay, plus 0 times 2 minus -12. Okay, and so this becomes -8 times 6 plus 12, which is 18, minus 7 times -22 plus 0, oops, not 10, plus 0 times this is going to be 14, positive 14. Okay, negative 8 times 18, that's negative 144. Negative 7 times negative 22, that's positive 154. And then we get plus 0. And so our answer becomes 10. Okay, so our determinant to this matrix was 10. Okay. Okay, let's do another one of these. Okay, how would we approach a 4x4? Well, we're going to make it easier on ourselves and give ourselves an example that doesn't take us the rest of the evening or the rest of the day, depending on the time you're watching this. Okay, so number 2, find the determinant of, and we're going to do a 4x4. Okay. So we have 0, 3, negative 1, 6, negative 1, 1, negative 2, 2, and then 0, 6, negative 12, 11, 0, 1, 5, and negative 3. Okay, so I'm going to be strategic in the row or column that I choose here because I just want to choose the row that has all the zeros so that I only have to do one 3x3 matrix. Okay, because the determinant of A here would be equal to, okay, 0, okay, times the minor, okay, or the signed minor. So what are the signs here? Well, again, if I do that checkerboard pattern, I always start with positive, okay, because I know 1 plus 1 is 2, and negative 1 squared is positive 1. So I always know that that first corner there is positive. And so we go positive, negative, negative. Okay, and then I could keep going like so. And so this would be negative, positive, and then positive, negative, and then negative, positive, positive. And I really want to focus in on this row or that column there because it only it has you know 3 zeros. So the determinant of A is going to be a 0 times the cofactor of 1, 1, but the cofactor is the signed minor, okay? It's going to be 0 times 1 times the minor of 1, 1, okay? And we don't have to get the minor of 1, 1. We don't have to calculate that out because it's going to go to 0 anyway. We're going to multiply by 0 and it's just going to go to 0. And so we don't have to worry about that. The other 3 zeros, we're going to get the same thing. I will do the next one here. The next one, we're going to go plus negative 1 times negative 1, or the negative of a negative 1, okay, times the minor of, this is row 2, column 1, 2, 1, plus 0, okay, times that positive 1, okay, for our sign, times the minor of 3, 1, plus 0 times negative 1 times the minor of 4, 1. Okay, and again, all 3 of these, 1, 2, 3, they're going to go to 0. Okay, so we're really just left with, this is equal to negative 1 times 1, which is 1, times the minor of 2, 1. okay? So 1 times 2, 1 is just 2, 1. Okay. So let's find the minor of 2, 1. Okay, so let's cross off row and column here. Okay, so we have the sign minor, or the cofactor, okay, times this -1. Maybe I should have, left it there for time being, but it's all good. Okay. So, so if we cross off row and column, then what's left over? Okay, what is that minor 2, 1? That minor 2, 1 is going to be the determinant 3, -1, 6, 6, -12, 11, and 1, 5, 3. Now we just have to find the determinant of that multiplied by 1. Maybe I'll put the 1 back in here. Okay, because that was the negative of -1. Okay, is equal to 1 times this thing. I don't know how best to describe that. Maybe I'll go back and I'll just say it's the negative of a -1. That's the signed minor. That's how I get this. Because, no, do it like that. Because I really want to emphasize that we didn't get rid of this -1. That -1 is being multiplied. It's -1 times the sign of the minor. Okay, the minor of 2, 1. So this again is -1 times the sign of the minor of the cofactor sign. I should say the sign of the cofactor, which is negative. It's in the negative position there. Okay, negative position, and so then we multiply that by the matrix. Okay, so let's find the determinant of this matrix here. Okay, so here we're going to do the same process that we did before. Okay, I'm gonna kind of speed it up a little bit because I already explained it once, but the determinant of matrix A here is going to be the determinant of this thing that we're just multiplying by -1 times -1, which is 1. Okay, times the determinant of 3, -1, 6, 6. Okay, so how are we going to find the determinant? Well, first thing, cross off row and column, assign my signs. Let's just use the first row here. Okay, and so this is plus, minus, plus. Okay, and like I said, I'm going to go a little faster just because, I don't want to get lost in the sauce. Lose the forest for the trees. We need to know how to do this, but I don't want to major on the minors and just look at all the nuances that we looked at before. I just want to teach you this is how it's done. Okay, so we're going to take the positive of 3, which is 3, and then we're going to find the determinant of -12, 11, 5, and 3. Then we're going to take the negative of a -1. The negative of a -1, that's positive 1. And then we're going to cross off the row. Okay, then we're going to cross off the row and column that -1 is in. And that's going to give me a determinant 6, 11, 1, and 3. And then I'm going to do a positive of 6. And so that's plus 6. And then I'm going to cross off the row and column here. Okay, and that's going to give me the determinant 6, -12, 1, and 5. Okay, so now let's evaluate these determinants. And some of this I'm going to do in my head. Okay, remember this is the motion that I'm going to use. Okay, and so I'm going to do some of the multiplication in my head. I'm just going to say, look, I've got 3 times negative 12 and 3, that's negative 36, minus 5 times 11 is 55. Okay, plus 1 times 6, 6 times 3 is 18, minus 1 times 11 is 11. Okay. And then plus 6 times 5 is 30, minus 1 times negative 12 is negative 12. And so we get 3 times you know, I think I left off a negative here. Let's pull that negative back in. Okay, so that we get the correct answer. Okay, so yeah, that was a negative 3 in the original right here. Okay. And so oops, back. These are so stripy. Right, let's move that. Now we can go up. Okay. So we have, this is going to be positive 36. Sorry about that. Positive 36, and that's going to be negative 18. Okay, so that's the only change there. Okay, so 3 times positive 36 and 57, that's negative negative 19, I want to say. Okay, plus this is going to be negative 29. Yep. And then this is going to be 30. Okay, 30 minus negative 12. So that's plus 6 times 30 minus negative 12 is 30 plus 12, which is 42. Okay, and then 3 times negative 19, that's negative 57. 1 times negative 29, that's negative 29. And then 6 times 42, that's 252, I believe. And when I add all that together, I get 166. Okay. Okay. Let me show you how you would do a determinant on the calculator. Let's go back to this guy here, okay, number 1, and verify that determinant is 10. Okay, so different calculators have different notation, different functions that they use, different um, you know, they set up the matrix. How you set up a matrix may be different. I'm going to use the TI-84 since it's just the most common in education. Okay, and so let me show my key press history real quick. Okay, and so using this calculator, if I wanted to set up the problem from number 1, I would go second, hit the second key, and then the matrix key, okay, which is the x to the negative 1 key. Okay, so my key press history is located at the bottom of the screen here. And so I go to, and I want to go over to edit. Okay, and I'm gonna go edit. Okay, and it says edit matrix A. I hit enter. Okay, and I want this to be a 3 by 3 matrix. Do not want a 3 by 4. I want a 3 by 3. Okay, matrix, and I want to plug in the values that we had from problem number 1. Negative 8, 7, 0, negative 1, negative 3, and 6, 4, -2, and -2, which is already there. Okay, and so we have matrix A. Now I have to quit out of this. I don't know why the calculator makes me do this, but in order to quit out of this mode, I have to go second, hit the second key, and then hit the mode key, and it quits completely out of it. Okay. Okay, and so now what I want is I want the determinant of matrix A. So how do I call up the determinant? Well, I go back into matrix. So that's second, not math, sorry. Second x to the -1, that's matrix. And I want to call this up, but I want to call up the determinant first. So let's go to math, and the determinant is function number 1 there. Okay. So we're going to hit math, and then we're going to hit the determinant. Now I have to call up matrix A. Okay, so I hit second, and then I go to matrix, and then it says names. What did I name that 3x3? Matrix A. So I'm just going to hit enter to call up matrix A. I'll close my parentheses. I don't know if that's really necessary, but then it calculates that determinant for me. Okay, we're going to be using this calculator a lot. You may consider investing in one. If you know, either that or the Casio. I think it's the 9750 that will do matrix operations. Okay, but we're going to be doing a ton of work with matrices. You know, chapters 4, 5, 6, and 7. Mostly. Okay, and then even into chapter 8, where we use matrices to solve some differential equations. But so yeah, make sure that I'm going to show you how to do the determinant by hand once here, and then for all intents and purposes, you're just going to verify these determinants with technology. Okay. Okay. Let's look at some properties of determinants real quick. Okay. Properties of determinants. Properties of determinants. Okay, let A and B be n by n matrices. So they're the same dimension, same square matrices. Okay. Okay. Okay, Pij, okay, if B is obtained by permutating 2 rows or 2 columns of A then the determinant of B is the opposite, the negative of the determinant of A. Okay, so if we know what the determinant of A is, we swap 2 rows or 2 columns in A, and then we recalculate the determinant. It's just going to be the negative of the original. Okay. MIK, if we multiply the matrix, okay, that's MIK, not IJ. If we multiply the matrix, a row in the matrix by K, then how does that affect the determinant? Okay. If B is obtained by multiplying any row of A by a scalar K, we'll call it scalar K, then the determinant of B is equal to K times the determinant of A. Okay, so we don't have to multiply, every row, we just have to multiply a single row. Okay, and then we get that to the determinant to become a multiple as well. Okay, what happens if we do a row operation on our matrix of I, A, J, K? Okay, I'll do our elementary matrices, multiply by our elementary matrices, A, I, J, K. Okay, if B is obtained by adding a multiple of any row of A, by adding a multiple of any row of A to another row of A, then the determinant is unchanged, which is kind of cool. Determinant of B is equal to the determinant of A. So doing those row operations, okay, or multiply and then add to eliminate a value, you know, turn it into RREF, reduced row echelon form, we'll have the same determinant, okay? The reduced row echelon form of a matrix and the original will have the same determinant. Okay, so number 4, the determinant of K times A. Okay, so if I multiply the entire matrix by K, that means all 3 of them, then that is 3 K's multiplied, or K to the nth power. Okay, however big, however many rows A has, this n by n matrix, okay, then that's going to get multiplied n times. K is going to get multiplied n times, which is just the exponent times the determinant of A. Okay. 5, the determinant of A transpose is the determinant of A. So the A transpose and the A, doesn't matter if I transpose the rows and columns, I still get the same determinant. It's a good one. Okay, number 6. Okay, if the rank of K, or sorry, the rank of A is less than n, okay, that means that we would get a row of zeros or something weird is going on, then the determinant of A is equal to 0. Okay, we're going to use this one a lot. Okay, so I would highlight that one. Okay, number 7. Okay, the determinant of A times B is equal to the determinant of A times the determinant of B. So that's helpful as well. Okay, multiply 2 matrices together two square matrices together, their determinant is the product of the original matrices, the determinant of the original matrices. Okay, number 8. If A is invertible, okay, then the determinant of the inverse is equal to the reciprocal of the determinant of the original matrix. Okay. Given that the determinant of the original matrix cannot be 0. Okay. If the determinant of the original matrix is 0, then it may not be invertible to begin with. Okay. And we're going to use this result as well. If A is invertible, then the determinant, okay, that's going to be a handy thing to know later on. Okay, definition. Okay, if every element of an n by n matrix matrix A is replaced by its cofactor, the resulting matrix is called the matrix of cofactors, and is denoted as M sub C. The transpose of the matrix, I'll say of this matrix of cofactors, okay, MCT is called the adjoint of A, and is denoted ADJ adjoint of A. Okay, so let's try one of these. Okay, number 3. Calculate the adjoint of J, sorry, the adjoint of A, if A is equal to 6, -1, 0, 2, -2, 1, okay, 2, -2, 1, 3, 0, -3. Okay. Incredible. Okay, remember that the cofactors are the sign minors. Okay, so we have plus, minus, plus, minus, plus, plus, or minus, plus, minus. And then plus, minus, plus. Okay, and then that's right. So then, okay, okay, so M sub C is going to be the matrix of cofactors. So let's just, I'm just going to run through this fairly quickly. How would I get the cofactor of 6? Well, cross off my row and column, and I get the -2, 1, 0, -3. And then if I take the determinant of that, that's 6 minus 0. Okay, -2 times -3 is 6. 0 times 1 is 0. So -6, or -2 times -3 is +6. So +6, okay, is, and then I look at my sign, look at this sign over here. Okay, I got the value, and then I look at the sign. Okay, the sign is positive. And so I replace this 6 with, well, another +6. That's just the way it worked out. Okay. If I look at the -1, okay, I'm going to cross off row and column this time, and I'm going to get a -6 okay, I'm going to get a -6 minus 3, okay, which is -9. But then I look at my sign over here, that's a negative. So I would get a -9. I would, again, cross off row and column. So cross off row and column, and I get 2 times -3 times 2 times -3 is -6. And then minus 3 times 1, that's -3, so that's -9. But then this over here, that negative makes it a +9. Okay. The 0, okay, I'm just going to, again, cross off row and column. Okay, cross off row and column there, and then I get 2 times 0, which is 0, minus 3 times -2, which is -6. So that's a minus -6, which is a +6. And is that positive? Yes, it is. It is positive. It stays positive because of the sign of the minor. The sign of the cofactor is going to be +6. Okay, and then we can do the next row. I'm just going to, again, run through this pretty quickly. Okay, so I'm not going to cross anything off at this point. But for 2, okay, for this guy, 2, I'm going to cross off row and column. So that's going to be 3 minus 0, which is 3. And 2 is a negative, so that's -3. Okay, -2, cross off row and column. That's 6 times -3, which is -18, minus 3 times 0, which is going to be 0. So -18, and it stays negative because there's a positive. Okay, I multiply by a positive, and so it stays negative. Okay, for the 1, cross off row and column. Okay, and I get 6 times 0, which is 0, minus -3, which is +3, and it goes negative. Okay, for the 3 at the bottom, cross off row and column, I get -1 minus 0. So that's -1, and it stays positive or it stays negative, -1. Okay, and then this one, for the 0, cross off row and column, I get 6 minus 0, which is 6, and it goes negative because of the checkerboard pattern. And then the last one here, cross off row and column for the -3. And I get 6 times -2, which is -12, minus a -2. So that would be -12 minus a -2. If you can't do that in your head, that's fine, just write it out. But that becomes -12 plus 2, which is -10. Okay, and so that is MC. That we don't have the adjoint yet, because we would need to transpose this. So the adjoint of A would be the transpose. Remember, I'm going to whatever is my first row becomes my first column. So that's 6, 9, 6. Okay, my second row becomes my second column, -3, -18, and -3. And my third row becomes my third column, -1, -6, -10. Okay, and that's my adjoint. Okay. Okay, why is the adjoint helpful? Well, there's a theorem that says if the determinant of A is not equal to 0, okay, then A inverse is equal to 1 over the determinant of A times the adjoint. So I could find the adjoint of A and then 1 over the determinant. That gives me the inverse. That's just another way to calculate the inverse matrix. Okay. Okay, so let's look at number 4 here. So it says calculate A inverse using the adjoint matrix if A is equal to okay, if A is equal to okay, 6, -1, 0, 2, -2, 1, and 3, 0, -3. Okay, so that might look familiar because that was what we used in the previous problem. We wanted to calculate the adjoint. Okay, and so if I want to find the adjoint, I just need 1 over the determinant. We already know what the adjoint of this thing is. Okay, the adjoint of A is equal to, we have it just above us here. Okay, 6, -3, -1, 9, -18, -6, 6, -3, and -10. So that's the adjoint. All I have to do is calculate the determinant of this. I could do it by hand, or I could do it on a calculator. By hand's not too hard because we got these zeros. So let's just do it by hand real quick. This is going to be the determinant of A is equal to 6 times, remember this is plus minus plus. And so this is 6 times the determinant -2, 1, 0, -3. Okay, minus -1 times the determinant of 2, -3, or 2, 1, 3, negative 3, and then plus 0 times the other term, that's just going to go to 0. Okay, and so this becomes 6 times 6 minus 0. Okay, plus 1 times negative 6 minus 3. Okay, plus 0, that just goes away. So this is 6 times 6, which is 36. Okay, and then minus 9. And so that becomes 27. So the determinant of A is 27. So now we can calculate the inverse of this thing. Okay, so let's calculate the inverse. So A inverse is equal to 1 over the determinant. Okay, 1 over 27 times the adjoint, which is 6, negative 3, negative 1, 9, negative 18, negative 6, 6, negative 3, and negative 10. Okay, so I'm going to distribute 1 over 27 to each of these and then reduce. Okay, and when I do that, like I do 6 over 27, that's going to reduce to 2/9. And then the next one is negative 1/9. And the next one is negative 1/27. And the next one is 1/3. And negative 2/3. And negative 2/9. And 2/9. And negative 1/9. And negative 10/27. Okay. So that's how we get A inverse. So we've seen 3 different ways to get A inverse. Okay, this is the third way. And let me show you a fourth way to get A inverse, and that's using a calculator. Okay, so we're going to introduce the technology today. Okay, so let's go back to the calculator. Okay, and make sure we have in our 3x3 matrix that we want to work with. So it's not the same because the last one was the determinant and it got 10. This determinant should be 27, but let's just verify. Okay, so we're going to go to second x to the negative 1, that's matrix. I'm going to edit my matrix A. Okay, so arrow over to edit and then go to matrix A. And now I want 6, negative 1, 0. Okay, 2, negative 2, and 1, and 3, and 0, and negative 3. Okay, so we have that in there. I'm going to go second quit, and then I might just pull this. Well, let's not do that. Okay, let me clear that. Let's just go to, let's find the determinant first, just to verify that we calculated the determinant correctly. So just real quick, I'm going to go to second matrix. I'm going to go math and hit the determinant. And then we'll go second matrix and then call up A, hit enter, and the determinant is 27. So that verifies that. Now let's get the inverse. Let's find the inverse. So to find the inverse, it's actually pretty interesting. We take and we call up the matrix, okay, A, and then we raise it to the negative first power, and that just tells the calculator using this x to the negative first power button, that just tells it that we're trying to find an inverse. And it comes out with these values. If I change those from decimals to fractions, I want to hit the second math. No, I just want to hit the math button. Yeah, not second. Hit the math button, and then it says to fraction. And I could say answer to fraction, and it comes out with my fraction answer, which is real nice. Okay, and so that verifies with what we got before. Okay. Okay, let's solve the system of equations by another method, and that other method was called Cramer's rule. And this will be the last thing we discuss in this video. Okay, Cramer's rule. If the determinant of A is not equal to 0, then the unique solution to A x vector is equal to B vector, okay, is x, the x vector, okay, equals x1, x2, x3, okay, dot, 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 all the way to xn, okay, where x sub k is equal to the determinant of B sub k over the determinant of A. Okay, so what's B sub k? Well, the determinant of B sub k denotes the matrix obtained when the kth column vector is replaced by the constant vector, by B. Okay, so B sub k is the matrix obtained when we replace that column, the kth column, over by the constant vector. Okay, the constant vector B. Okay, so let's do an example of Cramer's rule here. Okay, number 5. Solve the following system of equations by using Cramer's rule. Okay, now I'm not going to calculate all these determinants by hand. Okay, but I'm just going to show you how to do that. And then we'll. Okay, so if I have matrix A, if I have the system, okay, then I have -5 x1 minus x2 plus 2x3 is equal to -1. x1 minus 2x2 plus 7x3 is equal to 18. And 3x1 minus x2 plus x3 is equal to 4. Okay, so then A is my coefficient matrix. A is equal to -5, -1, 2, 1, -2, 7, 3, -1, 1. Okay, and if I were to find the determinant of A, okay, by any of the methods that we've shown, it's -35. So the determinant of A is -35. So now I need B sub 1. And so what would B sub 1 be? Well, I replace the first column here with the constants. Okay, and then find the determinant. Okay, so that would be -1, 18, and 4 would replace that column, and I would get -1, 2, -2, 7, and -1, 1, and I would find the determinant of B sub 1. And that's going to be equal to -35 as well. Okay. just by coincidence. Okay, and then B2, how do I find B2? Well, I take A, and instead of replacing row 1, I replace row 2 by my constant. Vector. Okay, so my constant vector, so row 2 gets replaced. Oh, wait. Okay, row 2 gets replaced by my constant vector. So my constant vector was my constant column vector, I should say, was -1, 18, and 4. And then I get from my original matrix A is -5, 1, 3, and 2, 7, 1. And if I find the determinant of B2, that's going to be equal to -70. And then if I take B3, what's B3? Well, I take matrix A and I replace the third column here with my constant column vector, -1, 18, and 4. And so that's going to give me -5, 1, and 3. And what's the second one? It's -1, -2, -1. If I find the determinant of B3, I get -105. And so how do I find x1, x2, x3, the variables that I'm searching for? X1 is equal to the determinant of B1 over the determinant of A. Well, that was -35 over -35, which is 1. X2 is the determinant of B2 over the determinant of A, which is -70 over -35, which is 2. And X3 is equal to the determinant of B3 over the determinant of A. And so that's going to be -105 over -35, and it's 3. So my solution is 1, 2, 3. And if you really wanted to, go back to the original system and plug 1, 2, 3 in. Okay, you want to go back to the original system and plug in the values 1, 2, and 3 for x1, x2, and x3, and you would see that it is a solution, is a unique solution to the system of equations. Okay. Let me scroll down for those who didn't finish copying that. Okay, I will see you. That's the end of chapter 3. That should take us up through the first exam, and I'll meet you again in the chapter 4. Okay.